I'm behind, but I'm always behind, so it's not a big surprise. Okay, let's not broadcast my chest the whole lecture long. Let's see if we can do the screen. Yes. Good, excellent. Quick, very fast, it seems. Okay, fine. Sun, learn. Learn, not sun. Okay. I wonder if it's going to ask me to log in, but it might. Oh. Okay. Okay. Log in. Almost there. That's my password. That's my username. That's my password. So let's start with topic number 1. Firstly, someone sent me a message asking if there is a test on the 26th. And the truth is that this message has been here all along, although I know it's not very clear. I'll now make it clear by saying that the only assessment of doing the tutorial, you must ignore the scheduled tests on the university's main roster. Since we do flexible assessment, we don't use those tests. Our only tests are in class 1. And they keep on scheduling them, even though I ask them not to. They insist on scheduling those. We are going to use the scheduled time during the exam. And there will be a second exam opportunity for people who have conflicts, because I know there are some who write something else, economics, or rational research, I'm sure. And if you have a valid medical excuse for not attending the exams, right here. But no test on the 26th, which I guess is next week sometime. There will be a practical test, a second practical test, and a tutorial test tomorrow on functions and arrays and functions. And I know there are no quizzes yet on functions, and if I'd been healthy during the holidays, I would have added them, but I just wasn't up to it. But we're still on track. Everything is still fine. I just feel like I'm about to die, but you'll survive. You'll carry forth my legacy. Apparently in oral form. So today we have to talk about libraries. The wrong date. I'm so used to writing the 20th. Yes. Yes, quickly, yes. Yes.
You mean the practical, comma, and the tutorial test?
No, I mean that you'll show up and you'll write the tutorial test as usual, and during tutorial time you'll write the practical test.
Oh, so they're both on the same day?
Yes, as we agreed last time. For postponing them. Sorry, someone else wanted to ask me a question. I very rudely said, no, ask me in a while. Why did you want to ask me? Sorry, say, guys, I can't hear what Janelle is saying. Please let her speak. She pays for this course, she doesn't like to speak. Speak up, Janelle. No. You can't make the, but it's a tutorial, it's scheduled. No, you schedule the whole of the afternoon is for computer science. If you have other arrangements, like, I don't know, your ball clubbing instructor is you then, or you have agreed to pick up a friend at the airport, I'm really sorry about that, because I can't keep on moving people around. So Thursday afternoons is computer science, that's eligible. Unless you have a subject like operational research, which unfortunately conflicts with computer science. When you do maths, you're not even allowed to take a different subject that clashes with your subject. So they don't even allow you to take computer science and operational research together. In computer science, we allow that, and we try to accommodate those students. And those people who have that conflict must send me a message so that we can agree on the time, like we did last time. There are other people who have illegal cuts scheduled for Thursdays, I know that other subjects like maths and also applied maths or economics, I don't know. Some people schedule their classes in this period. So that's not strictly allowed. But I don't want to make a big fuss in the university about keeping those open because you have a schedule problem. There are so many, and I'm so few. Yes. You've been hearing a lot about
conflicting things about
Friday the 28th of April. What did you hear? I didn't hear that. I thought it was just a regular day like any other. And the people, after celebrating freedom, we look forward to uniting together in the classroom and hearing about the people. So I haven't heard any of those rumors. I think that's fake news. That's fake news. That's legally fake news. Is there anything else you want to ask me or tell me? Okay, good. I don't want to be mean, honestly, but it'll be impossible to teach this class if we have to make special arrangements for everybody who wants to run out of the shop. I'm so sorry, Chantal. But guys, I have to stick to the rules. Oh, I hate being mean. Anyways, you guys have read all about libraries. Do you have anything you want to ask me about libraries? Nothing. Chanel? Nothing? Okay. For you about libraries. Let's. Oh, you smile so you be naughty. What's your name? Christina?
Yes.
Chanel, that's your real name. I'm to be glad. What do you know about libraries? What are libraries? You've seen them before.
Yeah, I've seen them before.
In passing, yes. What do you know about it? Sorry, yes. He doesn't know anything either. That's right. Okay. So, just in case you haven't exactly had time to read all the pages, and maybe I'll skip the last few or so, let me just recap quickly what you've missed. I'm not going to show you my slides, because you don't deserve to see them if you haven't read. And if you have read, you don't want to see them. That's horrible. But last time, we were writing this little function. I'm just picking a random function. We call it mystery. And actually, I wrote mystery to chat to you about how arrays are passed to functions, because that's something special. When we pass parameters or arguments to functions, they call them parameters, or sometimes formal parameters. In this case, mystery's formal parameters is v. And mystery treats its parameters like local variables. So we learn about local variables. Each variable has a scope, and its variables are local to that scope. Oh, sorry, a variable has a scope when it's local. It doesn't change outside that scope. I'm pretty sure I've deleted all the other versions of amazing, but I'll get amazing back by just doing undo, undo, undo. Let's see how it goes. Oh no, I think I'm undoing a little too much. Wow, did I write a lot of stuff? Oh man. Do I have to type redo a million times now? Can I just redo everything? I'll just. Okay, amazing's coming back. So apparently, amazing isn't the one that I used to show you the scope. But the fact is that if v was just an int, it would be a local variable to mystery. And changes to v would not be reflected outside mystery. The changes I make to v, it stays inside mystery, it's local to mystery. But as soon as I pass an array, what I'm passing really is not the array itself, but merely a kind of pointer to the array. So that the the y, so the x, what I pass to mystery here, it's just pointing to the array, and if mystery changes that array, the main function can see the change. This is not changing V, it's actually changing what V is pointing to. Changing the contents of the array. So, I could use this, but I want to use something else. I want to use a different function called Enigma that takes two numbers, and Enigma performs a really complicated operation on these two parameters. Enigma performs a really complicated operation on these two parameters. It's adding them. But for that, today we're going to pretend that adding is a really complicated operation that consumes a lot of resources that took at least a week to implement. So we have this function Enigma. We've written it. Why have we written a function Enigma? There are two reasons. Firstly, it makes your code clearer. If you have one main function that does, let's say, plays your whole game of to-do code. If you have one main function that does that, it's going to look really complicated. So it's much nicer if you write a function that does something that's simple, like draw the board. That's a nice function. It does one thing, it draws the board. It's simple to understand, so you write code for other people. They can read it more easily. In your main function, you simply invoke or call, draw the board, and it happens if the function implements that. So we're clearing up our code, we're making it cleaner. And the other reason we write functions is to avoid repetition. If I need to draw the board 5 times in my main function, I don't want to repeat that code 5 times. It's probably a lot of code. So putting it inside a function means I can just call that function 5 times, and the complicated code I only have to write once. If I make a mistake in the complicated code, like let's say I want Enigma was supposed to add, but I wrote subtract. If I find out that there's a mistake in my code, I only have to fix it in one place. I only have to fix this minus sign and make it a plus sign, and it's fixed everywhere. So that's a relief. Everybody who uses this function will now get the right function. And we all make mistakes, so this is an important part of life. Okay, right, so I'm going to save this. I'm going to save it, and I now have this function Enigma. In fact, I can pack Amazing with a lot of different functions that are useful. And they may all be tied together to do something amazing. They all have to do with the same kind of thing. If I write a second program outside Amazing, so let's write a second function that's called, well, that's called Amazing. So I'll call the second class program Quite Ordinary. Okay, so Quite Ordinary needs a main. It wants a main. I'll give it a main. And it has 2 values. X, that's that number, and Z, that's a different number. And now I want to add them. But addition, remember, is a really complicated operation. I've already defined it in Amazing, and I could go to Amazing and repeat this code. Just steal the code, repeat it inside Quite Ordinary. Or I can use Amazing as a library. I can say, Y is amazing.enigma. Z, this should be an X. And I'm not sure what this will print. I'm too ill to add, but this is, now I'm using Amazing as a library. So I've got my main class, Quite Ordinary. It's got its main function inside. And it's using Amazing. It's calling Amazing and using the functions inside Amazing. And it can do that because Amazing is, firstly, all these publics, keywords that we've never understood. All these publics mean that what Amazing is declaring, the functions, methods it's declaring, are publicly available. I could have made them private, in which case I couldn't see them from outside. And sometimes I may want to do that. I don't want to show the inner workings, all the inner workings of Amazing to the outside world. But mostly I have them public. I'm not even going to say more about this because this really comes into its own in the second semester, the second course. And the second reason I can call Amazing is that it's right here next to Quite Ordinary in the same, what it says at the top here, package. And if it were somewhere else, I'd have to do a few tricks. In fact, I've already had to do a few tricks to get to some libraries that I find really useful, but that are not in this package. If I wanted to, instead of, where's Quite Ordinary, instead of doing a print line, if I wanted to do standard out.println, Java complaints, Eclipse complaints, because it doesn't know this library standard out. It's a different library. I'm using its println method, but I have to tell Eclipse, or Java actually, that I need to import edu.println.cs.standard. So that little import statement at the top says, I want to use this library that you've never heard of, but I want to use it. And this is its name or address, what have you. And now I can use standard now. I think it would have worked if I did the same thing for Amazing. Let's not delete code. This is all on YouTube, isn't it? YouTube? YouTube, are you there? Yes, you are. Good boy. Right. This is all on YouTube, so that's fine. It won't be lost. I think I could have said, I'm not even sure, import Amazing. Amazing. Okay. Oh, no, it doesn't like that apparently. What is it complaining about? Cannot be, doesn't know where it is. Okay, that's fine. We're not going to do that. We're not going to find out why. We'll just leave it as a mystery. But you've used, Janelle, you've used libraries since day one, haven't you? Have you? Oh. Which one? Which one?
The ACD, the system.
Oh yes, the system one, yes. Not the STD. No.
Sorry.
System. The system is a library, and it has something called out, which is a kind of library inside the library. Don't want to go into details, don't want to talk about it. Very personal, sensitive topic. And println is a method that's defined just like Amazing or Enigma. And I'm sending it the Y. So we've been using libraries for a long time. We've been using things like math.sign. If I can type it correctly, math.sign. Come on, Eclipse, work with me. Math is a different library, and we've been using it like this. We're very happy. In fact, I've been negligent. I should have explained to you that math is a library, but I kind of just glossed over it and said, Java, the name of this function is math.sign, and don't ask any questions. But no, math is actually the library, and sign is the name of the function inside the library. In real life, oh, now I'm going to do something that YouTube can't see. Oh man, I wish this wasn't necessary, YouTube, but I'm afraid I have to. But I'll put these and the other drawings I've made in the past online. I promise. So, I want to draw a little picture. I'll show it to you, YouTube, just so there's a record of it. But why do you have to use libraries? No, but you'll be the only programmer in the world who doesn't. Using libraries is not a bad thing. They're there to help you. In fact, they may actually help with what we've done from the very first day of this course, Janelle, the very first day, and that is with problem solving. Because when we problem solve, we are, in a little sense, using a library. Do you remember any of the puzzles, Janelle?
I studied music for the first 2 weeks.
You studied music for the first 2 weeks. What did you do music for the first 2 weeks?
Not puzzles.
But you can pick something up and I can do cross interdisciplinary teaching. What did you do the first week? Do you remember?
Yeah. Sorry. We had to choose our repertoire for the practical part of our degree. So we had to
repertoire.
Yes. So we had to choose from,
What did you choose? This is good stuff, people. I'm working.
I chose the Scarlatti Sonata.
Scarlatti Sonata, yes.
And then Shostakovich Prelude.
A what?
Shostakovich.
Shostakovich. I saw the movie. It was brilliant. I love the part where he goes through the hole behind the Rita Hayworth's house. Okay, I don't know Shostakovich. I've never heard of it. What is it doing? Russia. Shostakovich.
Yes.
Shostakovich, yes, not Shostakovich. Shostakovich, yes. Yes, I don't know Shostakovich, I've never played Shostakovich, but I have played a lot of Scarlatti, and it's horrible. It's ugly, and it's just a lot of exercises. Because all his music is for people who can't do music. That's what I was doing, why I was doing it, and it's just for exercising your finger. So, that's not true, but you know what I mean. Now, you missed the part where we did 2 weeks of solid problem solving. And we had lots of puzzles, we learned different techniques for solving those problems. And the idea was that you'll be given problems in this course, like in the TUTs. Let's see if we can go to the TUTs. YouTube is still running. Let's go to the last TUT. If I can, go back one page. Tutorial 7. So, oh no, that's boring. Oh well, that's kind of, well, here we go. So, you're given the problem of calculating the average of a lot of grades, and there's a little instruction about how this program should be working. And in fact, there's not a lot of problem solving needed, because I don't want you to struggle with that too much. This is the early stages. But let's just say, we are just asked to calculate the grades for a big class. So when I try to solve this problem, where do I start? We learned different techniques, didn't we? We learned about, can you read that? Yes, okay. We learned about induction. Can I solve the problem but just one size smaller and then extend the solution so that it works? We learned about something else that I can't recall. Divide and conquer. Did we learn about that? Oh, invariance. That was, I knew it started with I. Say I knew. It's easy to say now. Invariant. That's right. So you try to maintain some invariant, but try to do something to the problem so that the invariant stays the same, but you're getting closer to the goal. The invariants were like taking marbles out of a bag and the number of black and white marbles stay even, something like that. Induction, I can't really call the puzzle, but divide and conquer, we definitely did the goat and the cabbage and the farmer, we tried to the wolf. Did we do that one?
We call it decomposition.
Yeah, we did call it decomposition, you're right. We did call it decomposition. I was about to say that. But often in computer science, we just call it divide and conquer. It's the same thing. It's also called other things. It's also called top-down design. It's got different names. So the idea is I've got a big problem and I want to break it down into smaller parts. Now, I don't think the grades problem is the best example of that, but let's find a different kind of problem that we can break down. And to show you how libraries work. So, Let's say my problem is to write a game. Let's say it's a game called tic-tac-toe. I have to implement this game. Where do I start? How will the game work? Well, I'll definitely have a program. So I'll have a library, if you want to call it that, a module, a part, that does the whole game. So I'll have my game. But how does it work inside? There has to be some routine that runs. Well, there will be a main. I'm sure there will be a main here. And what will main do? It will start up and initialize the whole game. And then it will repeatedly ask me for a move and display the board. And it will compute the computer's move and display the board. It will ask me for a move and display the board, computer's move and display the board. So it's going to have some kind of loop inside. That's not going to influence my module structure. But those functions that it does inside that loop, it's other functions, that all influence me to some extent. It's something that I may want to place in a different module. I'll call it interface. Drawing the board may be a routine that I'm calling in a different library that I'm going to write. And maybe I call that library an interface because that's the interface between the game and the user. And TTT, my main game, the details of drawboard. That's one of the great things about a function or modules and libraries. We don't know how math.sign works on the inside, do we? And one of the questions was to calculate your own version of the sign function. But this is not. Why are you frowning, Janelle? Didn't you do this in music? Sign is such an important part of music. It's the sign wave, harmonics, music. We don't know how math.sign works on the inside. You don't know if it's using this formula or a different formula. You don't know that it's really just using a table. So, a function and a library hides things from us. It hides the details, the complicated details. I never have to think about how to draw the board again. I can carry on with designing and writing TTT and main, this main library of mine. And this is hidden. The details. All I need to know is that there is something like this, and I can call it when I want. And it may be that when I initialize, I can tell this library called interface. This time, I'm playing on the command line. And in that case, when I call draw board, it will draw the board on the command line using ASCII characters. Or I could tell interface at the start of the game, I want to play in the graphics environment. And then when I call draw board, it draws something on the screen using standard draw or option panel or anything else you want, as long as it satisfies the requirements. But that's all hidden inside drawboard. So I've hidden the complexity. Hidden the complexity like this. And there are other things that I can think of as libraries. It's going to interact with me, it's going to ask me for value, and if interface is going to handle the whole interface of the user, it's probably going to do that part as well. Read move. Can you see that? Read move. Okay, good. Something that interface will not be handling is how the computer computes its move, but there may be a different library called computer. Okay, this pen is dying. I'm sorry to say, it wasn't made for paper. And I'm sorry to say I've left all my pens in my office. That's fine. I'll just carry on with this pen. I'll give it its last lease on my hours. Oh, what do I do now? It's different. Oh, it's got different sides. Oh, computer AI. Okay, it's going to be a new lease on life. Right, amazing little pair. Computer AI. And it's maybe the AI that calculate, next, move. And inside main, I invoke this routine. I call that, but main doesn't need to know how it works. All it does is on a very high level, it says, do this, do that, do this, do that, by calling functions. So even before I write any code, I can think of different libraries that would be really useful for me to have in this game. And I can tell myself, well, I could start with TTT and write that. But it may be that I do a lot of work and write TTT, and then I discover, when I'm writing interface, that things don't work exactly as I thought. The structure needs to be a little different. Maybe this isn't the ideal way to organize my libraries and methods. And then I've done all this work. So usually we say it's best to start at the bottom and work our way up. Start with these outside libraries and functions and write them first, and then we get to the main. But that's a matter of taste also. Some people do start at the top and write all their code from the top down. To write this code and say, okay, this is my final code. All I need to do now is to implement these functions that I've to do the work that they said they would do. So, well, let's just leave it there. What else do I have to say about libraries? What are the slides? I wouldn't show them, but now I'm kind of doubting myself. Maybe I missed something. I'll answer your question in a sec. Let me just get my slides up and running. Libraries. Libraries. It's opening. Yes. Okay. No, that's the wrong button. Oh, that's the right button. The right button for making it disappear. Okay, fine. Conrad, what did you want to ask me?
Should we make our project so that it has separate libraries or just separate functions in a single class? Because if we have separate, if we create new libraries, we then have several files that we have to do separately.
Definitely. Oh, it's playing by itself. Okay, no, just give me a second. I pressed the wrong button. Sometimes it starts playing, that's fine. Yes. Yes. What was the question?
I was asking, should we put everything?
Yes, you should. Or you should. Yes. One or the other. Is that what your question was?
Should we put everything into one file or shouldn't we?
Yes, you should or you shouldn't. So I'm kidding you because you're asking A or B. I'm saying yes, A or B. No, you shouldn't. No. It's insane to put everything inside one file. Technically, Java has a requirement that if you write a class called quite ordinary, that should go in a file called quite ordinary with Java. And if you write a file called amazing, so a class called amazing, it should go in amazing.java. Now, sometimes Java is naughty, and it allows us to actually, are you studying computer science now, or are you still at music? Oh, you switched? Oh. Why did you switch? What? Some of my best friends are studying. Well, Eclipse won't allow me to do this. But sometimes, under some conditions, if I did this right, Java allows me to put more than one class in one file. It's a good thing if you can't manage it, and I can't manage to do that either. There are certain rules. Please don't tell me the rules. I'll just figure it out on my own. So yes, you'll end up with several files. One called ordinary.java or board.java, one called interface.java, what have you, and you'll have to hand in several files. But that's the way to do it. So now, coming back to you, this is like music. Oh, what were your instruments? The accordion, yes. Yeah, organ. Oh. What organ? The thing is, you can't do anything with a music degree. Yes, you can teach, and you can play the piano and the organ, but 1 out of 1,000,000 people become international concert pianists or international concert organists. There are such people. But that's not important. Don't think about what you can do with your degrees or subjects. Please study what you like. I mean, that's much more important to study what you have a passion for. Kilimanjaro's passion wasn't for the organ or the piano, but it does like pressing things down with buttons. Most buttons, like so press. That's good, good, excellent. Yes, I hate the organ. I was going to show you my slides. Right, libraries and clients. That's beautiful. So maybe I neglected to mention that quite ordinary, when it was using the library amazing, became the client, as we say, of amazing. So there are libraries that offer services in the sense of having methods and other files programs to call, and there are clients who use those services. Okay, guys. It's fun. It's nothing. My mistake. Okay, right. Libraries, yes, cool. They use a very different example. I would too feverish to do this today. They call one called Gaussian, and we just use amazing. But phi was their function, but Enigma was our function. Then, what is nice on these slides and in this book and in the whole Java system is that documentation is an important part of Java. And in this book, at least, they list the APIs like this. You've seen this many times because you've read the book thoroughly. Amazing as well. We could have, we still can. Where we list the class and all the functions that it exports, that it makes visible, that it makes available to the outside world. So, let's switch this back so I can point on this side. There we go. And then lastly, you actually have the actual implementation because you have to write the code at some point. You can't just not ever write the code. But the great thing about an API, designing it carefully, is that you don't need the implementation. You can worry about that later. And if you know exactly what the API will be, you can start using this library. You can start using Amazing, or we can start using interface without knowing exactly how I'm going to implement it. I'll worry about that later. Yes. Okay, so this picture is here because the example was all about random numbers. How to make a new kind of random number. And in that case, it's useful to talk about this guy called John von Neumann. He was a kind of computer scientist / mathematician / operational researcher in the early part of the 20th century. And he's next to a computer called ENIAC, which is one of the first computers, but definitely not the first computer. What was the first computer? Don't answer because you'll be wrong. Yes?
We mean the first computer to be built or the first theorized
computer? What do you mean by computer?
Well, that's a good question, really. But I would say.
Why did you ask it?
I would say maybe Charles Battersby's differential engine.
What is a computer?
At least I was the first one that actually had a computer program for it by updates. As we know that today.
Maybe. Not saying you're wrong, so you're right. So what do we mean by computer? If we just mean calculator, then we'll have to go to the abacus, as far as we know. Because the abacus is quite sophisticated. And it executes instructions that you give to computer by moving your fingers and moving beads around. And it's not much different from us pressing keys. So it does qualify as a computer. And then there were many, many different machines. Pascal invented a calculator. Leibniz invented a calculator. Babbage invented a calculator. And then he invented what's called the difference engine. But never built that. I'm sorry, he invented the difference engine was the calculator. The analytical engine, which is like version 2, was the never built real computer. And then during the war, people built all kinds of computers, and they're still kind of fighting over which was the first. If we talk about electronic computers, there are just a few candidates. Something called Colossus. There's something called the Z4, Z3, I guess. There's something called ENIAC, and this is ENIAC. So who saw that Alan Turing movie about not the connectionist, like the what?
Protection method.
But meditation.
Imitation.
Imitation, that's right, imitation. Why was it called that? Right, but there's a plan of words there. So, the imitation game showed that computers that they had the bomb with all its stars, and it was kind of early computer. They actually built a different computer that eventually called that was more real, more general computer. But they all looked basically like this: enormous machines filling rooms and rooms that could do practically nothing. These ones were still made with valves, vacuum tubes, that were about this size. Maybe they grew a little smaller, but eventually they were replaced with transistors, which are infinitesimally small, basically just a few atoms these days. So, that's just a picture of a human, and he wrote a few things about random numbers, saying that computers can never truly be random. We can always predict what the computer will do. So how can you get randomness out of that? And made a few statements, but not important. Any case, blah, blah, blah. So all of this stuff is just really an illustration of what the book, the example of the book uses. I kind of have to stop because I've kind of run out of things to say. But on Friday, tomorrow you write your 2 tests. So one will be a practical test, one will be a tutorial test, and I'll be one after the other, and then I'll see you again on Friday. I should have plugged this in. It's 3 o'clock, yes.